Children, let's do an activity and some problems from critical angle and total internal reflection. So one problem is here. Determine the refractive index of benzene. So determine the refractive index of benzene if critical angle of benzene with respect to air is 42 degrees. Critical angle of benzene C. C is equal to 42 degrees. What is the formula of C? Sin C is equal to 1 by refractive index. So sin 42 is equal to 1 by refractive index of benzene. So refractive index of benzene is equal to 1 by refractive index of benzene and 1 by sin 42 is equal to 1 by sin 42 is this value is 0.6691. So answer is 1.51. This is the refractive index of benzene. So the absolute refractive index 4 by 3. What is the critical angle? So we find critical angle. Absolute refractive index is 4 by 3. So formula is sin C is equal to 1 by refractive index is equal to 1 by what is the absolute refractive index? 4 by 3. So 3 by 4. So 0.75. C is equal to sin inverse 0.75. Critical angle of water is equal to 48.5. This is the critical angle of water. Children, let's do one activity. What is the aim of this activity? Explain the phenomena of total internal reflection. What materials we required? Cardboard, white sheet, laser light, protractor, semicircular glass slab, scale, pencil. So these are materials we use. Children, take a wooden plank which is covered with white chart. Draw two perpendicular lines passing through the middle of the paper. See here. Let the intersecting points be O. So mark one line as NN, which is normal to the another line marked as MM. Here MM represents the line drawn along the interface of two mediums and NN represent the normal drawn in this line at O. So what did you understand? MM is the line, the interface of the two mediums. So NN is the normal. So take a protractor and place it along NN in such a way that its center coincides with O. See here, children. Then mark the angles of 0 to 90 degrees on both sides of the line NN. Repeat the same on the other side of the line. So the angle should be represented on curved line. So see here, children, place the semicircular glass disc in such a way that its diameter coincides the interface line mm and its center coincides with the point O. See here, children. So now send the light from the curved side of the semicircular glass slab. So the light travel from denser medium to rarer medium. Start with angle of I equal to 0 degrees and observe the sides of the observe the incidence angle and refracted angle. So send the laser light along angles of incidence 5 degrees, 10 degrees, 15 degrees, 20, 25. So and the calculate the uh, see the refracted angles also. So note the incidence angle and the refracted angle in the given table. So refracted angle is 90 degrees. See here children, at the particular angle of incidence, the refracted ray traces along the interface separating the air and glass. The angle is called the critical angle. Where the angle of incidence is greater than the critical angle, the light ray is reflected into denser medium at the interface. Light never enters into rarer medium. This phenomena is called total internal reflection. What do you observe in this activity? At the particular angle of incidence, the refracted ray traces along the interface separating the air and glass. The angle of that angle is called the critical angle. So, when the angle of incidence is greater than the critical angle, the light ray is reflected into denser medium at the interface. Light never enter into rarer medium. This phenomena is called total internal reflection. So, children, we had already observed, noticed. See, children, N2 is the rarer medium, N1 is the denser medium. So, N1 sin I is equal to N2 sin R. N1 by N2 is equal to sin R by sin I. So, N1 by N2 is greater than 1. That sin R by sin I is also greater than 1. C is the critical angle. Then R becomes 90 degrees. We already known. N1 by N2 is equal to sin 90 by sin C. So N1 by N2 is equal to 1 by sin C. Sin C is equal to N2 by N1. Sin C is equal to N2 by N1.